Hello and welcome to the WeatherOps Spring Severe Weather Outlook for 2013. I am WeatherOps meteorologist Chris Kerr, and alongside me is meteorologist Brandon Lawson. Here's a quick look at what we'll be going over this afternoon. We'll take a look at severe weather episodes that have occurred late this winter. We'll examine why the current El Niño Southern Oscillation Index is neutral and determine if this will continue into spring. We'll also take a look at the current Arctic Oscillation Index and determine if this will also change as we go into spring. We will provide an update on the ongoing U.S. drought. We will give our temperature and precipitation outlooks for spring. And we will identify the regions of the United States likely to see the greatest severe weather impacts this spring. Let's take a quick look at 2013 thus far. 2013 got off to a fast start severe weather-wise in late January. Many of you in the southeast will remember the tornado outbreak of January 29th through 30th. 83 tornadoes were reported in 10 states. A very strong EF3 tornado struck the city of Adairsville, Georgia in the early afternoon, causing widespread damage. This particular tornado was very well documented by both amateurs and professionals alike. A little over 10 days later, on February 10th, another tornado outbreak occurred over the south, this time over southern Mississippi and Alabama. Most of the tornadoes were fairly weak, but one of the tornadoes was an EF4 that caused catastrophic damage throughout the city of Hattiesburg, Mississippi, and also on the campus of Southern Mississippi University. With these tornadoes, there were miraculously no deaths, but there were many injuries and reports of major property damage. A little over a week ago, severe storms tracked through parts of the south. Everything from tornadoes to wind to very large hail occurred. The tornadoes were generally low end, but caused some injuries and property damage. Perhaps the most impactful event was the large hail. Some areas of Mississippi and Alabama saw up to baseball-sized hail. So as you can see, there were some impactful events in the first 3 months of the year. But why has this year been relatively quiet compared to the beginning of 2012? For one, many strong cold fronts tracked through the Gulf of Mexico late in the winter, which essentially scoured out the quality moisture that is needed to fuel thunderstorm development. This, combined with colder than normal air, has put a damper somewhat on explosive and widespread severe weather development. When low-pressure systems do move through the southern plains and southeast, moisture is not able to be advected north fast enough to generate widespread severe weather development. The Arctic Oscillation and a neutral El Niño, which we'll get into in just a minute, has also had an effect on severe weather. Also, I'm sure many of you are wondering why it has been so cold in some parts of the U.S. recently. For that answer, we look to the Arctic Oscillation. The Arctic Oscillation, in simple terms, is the back and forth movement of sea level pressure generally north of 20 degrees north latitude. A positive Arctic Oscillation signifies that lower pressures are present over the Arctic regions of the northern hemisphere. This in turn means that jet stream is fairly far north, generally north of the U.S.-Canadian border, which helps keep colder air in place north of the United States. Conversely, when the Arctic Oscillation is negative, higher pressures are in place over the Arctic, which allows for dips in the jet stream, which in turn causes lower pressure and temperature over much of the eastern two-thirds of the United States. This is exactly what we have been seeing as of late. High pressure over the Arctic allows an atmospheric traffic jam of sorts to occur, essentially blocking weather systems from moving quickly through. A quick note that zonal flow, for example, generally west to east flow, is present during times of a positive Arctic Oscillation, which allows weather systems to move quicker and cold air to stick around for a shorter period of time. Here's a graphical representation of what I just talked about. As you can see, we here in the U.S. are not the only ones experiencing cold weather as of late. A negative Arctic Oscillation has a very similar impact on much of northern and western Europe. We have talked about what has happened for the first 3 months of 2013. Now let's look ahead to what we expect for the rest of the spring. For that, I will turn the presentation over to Brandon Lawson.
Thank you, Chris. As you mentioned, spring does feel like it's off to a slow start, and in general, this is a good thing. Less severe weather is best, unless one of your hobbies happens to be chasing severe storms. In that case, the slow start has probably been a little bit frustrating. But I want to point out or stress that a slow start to the spring does not necessarily indicate that we're going to undergo a mild severe storm season. In fact, while a late spring season is not an indicator of more severe weather, the outbreaks that do occur have a much greater chance of being more significant. The reason for this revolves entirely around moisture. As you can see, moisture is usually confined to the Gulf states during early spring and does not typically expand further north until late April-May. Sufficient moisture for severe weather setups is not as common during the month of February through March, and sometimes it's not even around during April. What this means is that early spring storm systems that track through the plains and the southeast regions are usually characterized by high shear and low instability. The low instability stems from a lack of quality low-level moisture. High shear, low instability setups do produce outbreaks, especially across the southeast, but they are less common. Another thing to consider when we look at spring from a severe weather perspective is that the season is all about upper air patterns. These patterns tend to cycle between active and inactive periods through the duration of spring, and a lot of our severe episodes are a matter of lucky timing. If and when the pattern becomes active, it can coincide with an abundance of good moisture. So what are some of these good and bad synoptic patterns for severe weather? The most favorable upper air pattern for severe weather is sometimes referred to as western troughing. This is when low pressure resides over the western half of the U.S. and high pressure over the southeast or Gulf of Mexico. What this does is it allows for mid-latitude cyclones to dig across the central U.S. and lift into the eastern half of the country, along with favorable return flow at the surface for moisture to return and northward into the plains. This is typically what forecasters and storm chasers alike keep an eye out for during spring. There are also some of the patterns that are generally bad for severe weather. The first is when you have an eastern trough and high pressure over the western conus. This is known as a blocking pattern and prevents mid-latitude cyclones from moving east into the central U.S. A second unfavorable pattern is commonly referred to as a death ridge, where a strong ridge of high pressure develops and remains over the central U.S. for an extended period of time. For spring 2013, we've been in a bit of a lull in regard to severe weather, but things have actually been fairly active as far as our weather pattern is concerned. The central and southern plains have seen several rain events, as well as much needed snow. As we move into the heart of spring, and if our active pattern can continue, we're likely to see our severe weather chances increase with each new day. So where are we now? Our weather is strongly influenced by different ocean atmospheric paired oscillations around the globe. As Chris discussed earlier, the Arctic Oscillation has helped with much needed rain and snow across the plains. Currently, the Arctic Oscillation is very negative, and this has allowed our polar jet to be somewhat active for us. The graphic shows observed and ensemble forecast of the Arctic Oscillation from December of 2012 to April 1st of 2013. You can see that we're very negative at about -5 through the middle of March, with the ensemble models forecasting us to go back to a neutral value by April 1st. However, this is unlikely to occur that quickly. Based on observations, the Arctic Oscillation has just bottomed out, and there's no indication that it's going to rapidly accelerate to a neutral value within the next week or two. So, we're expecting the Arctic Oscillation to become less negative over the next couple of months. This will allow for our temperatures to rebound over the coming weeks. However, it's unlikely that our Arctic Oscillation will rebound to a neutral value as quickly as forecast ensembles indicate. What this means is that the polar jet will likely remain fairly active over the coming months. A common topic during spring is El Niño and La Niña. These conditions are part of the ENSO, or the El Niño Southern Oscillation, and they lead to unseasonably dry or wet conditions for various parts of the country. Here we have a table with ENSO values for the last 10 years, ending with the latest 3-month anomaly average for December of 2012 through January-February of 2013. And currently, we are in a neutral phase, which lends itself to a fairly average year of severe weather. Not an extreme number of outbreaks, but not too few either. We expect the ENSO to remain neutral through late spring, early summer, with a trend towards positive conditions by early fall. Having said that, it should be noted that the ENSO is not a guarantee of an active season, an average season, or an inactive season. During the 2003-2004 period, the ENSO was also neutral going into spring, but 2004 was a very active year with several notable outbreaks such as May 29th across northern Oklahoma and southern Kansas. Here's an ensemble forecast for the ENSO with values approaching 0 by early 2014. There's usually a lag from El Nino and La Nina transitions, so it's not likely we're going to see any immediate impacts for a positive trend this year. And with that, I'll turn it back over to Chris.
Thanks, Brandon. Now let's take a look at what we are expecting the general pattern to be like throughout the remainder of the spring. As is typical of spring across the U.S., low pressure troughing persists over much of the central part of the country, with high pressure flanking on either side. This year we are expecting much of the same. To get an idea of what a typical or average year looks like, let's take a look at a graphic. In this graphic, courtesy of the National Weather Service Storm Prediction Center, we see the average number of thunderstorm watches over the past 20 years across the U.S. As would be expected, the highest concentration is over the central part of the country. We are expecting the heaviest concentration of storms to shift slightly to the northeast of this area this spring. Brandon will get into that more in a bit. Now let's take a look at the ongoing drought over the U.S. and what impacts it may also have on severe weather this spring. On this very busy map, it is clear to see that the drought has its grip on a majority of the country west of the Mississippi River. Through the spring and most likely into the summer and fall, barring any heavy beneficial rains, drought is expected to persist. However, some areas have seen a small improvement thanks to light to moderate recent rains. Drought has a profound effect on severe weather in that drought-stricken, dry soils allow for very little to no evapotranspiration into the atmosphere. Thus, there is little quality moisture to generate thunderstorms. In simple terms, evapotranspiration is the transfer of water vapor from the ground or vegetation to the atmosphere. Evapotranspiration, combined with quality moisture transported from the Gulf of Mexico, for example, can allow for strong to severe thunderstorms to develop. However, just because evapotranspiration may be non-existent does not mean that severe weather outbreaks are impossible during droughts. For example, the May 24, 2011 tornado outbreak over the central and southern plains occurred during a strong drought. Now I'm going to pass it back to Brandon, and he will talk about our temperature and precipitation outlooks for the spring.
Thank you, Chris. The current drought over parts of the desert southwest, the Four Corners region, and much of Texas, and the fact that the drought is expected to persist will likely impact the number of troughs that actually dig deep into the southern plains and southeast this spring. The current neutral onso does not suggest unseasonably wet or dry conditions for any specific part of the country, with a trend toward a positive El Nino not really materializing until later this year or early next year. Therefore, we anticipate mid-latitude cyclones taking a slightly more northerly track, as Chris mentioned, with lows digging across southern Kansas and ejecting into the Midwest region. The upper Midwest, Great Lakes region, and Ohio Valley stand a good chance at seeing above-average precipitation going forward into spring. Conversely, below-average precipitation can be expected across the western third of the country, as well as further south for areas bordering the Gulf of Mexico. And with those dry conditions expected for the south, above-average temperatures will be possible from the southern high plains into the mid and lower Mississippi Valley, with below-average temperatures across the Pacific Northwest. Once again, here's the expected general pattern for this coming spring. What does this mean to you? Here's a look at the areas most likely to have the greatest severe weather impacts. Conditional severe impacts will exist over the central and southern plains, especially west of I-35, with areas eastward into the Midwest and lower Mississippi Valley having a more substantial risk for severe weather impacts. Here is largely the same graphic broken up into early spring, late spring, and early summer. The southeast has not seen a lot of severe weather this year, other than what we touched briefly upon at the beginning of the presentation, but a few severe weather episodes will be possible over the next 3 to 4 weeks, before we move deeper into spring and the focus for severe weather shifts into the central plains and eastward. With a general pattern of low-pressure cyclones moving across south-central Kansas and then lifting off to the northeast, eastern Kansas through Missouri and into the Midwest will have the highest chance for severe weather now into early June. And then that threat will shift into the upper Mississippi Valley and portions of the Great Lakes as we move into mid-June and July. Let me pass it back to you, Chris, and you can talk about what we can offer your clients and their assets.
Thanks again, Brandon. With WeatherOps services, we can help you stay ahead of the storm by providing the following: twice daily email alerts and discussions, conference calls and webinars that work around your schedule, custom data layers integrated into your IMAP Pro instance, and desktop video presentations. We can also provide a fully customized 7-day outlook or event planner with weather triggers that are tailored to your specific project or outdoor event. The basics of our 7-day planner include high and low temperature, expected sky cover, wind speed and direction, and sun and moon data. This planner will be sent by 6 a.m. local time every morning by one of our meteorologists on staff. Also, if we are forecasting for an event such as an outdoor concert, we can provide you with a weather check, which is modeled after a sound check. With a sound check, you want to make sure that all of your instruments are in order, your staff is on the same page, etc. The weather check is designed to provide a quick reference on the expected 2-hourly weather for the day of the event. This will also be sent by our meteorologist at 6 a.m. local every day of the event. We hope that you've enjoyed our presentation today and that it has provided some insightful information on the upcoming severe weather season. If you would like to utilize our services this spring, please contact Dax Cochran at 405-476-6671 or send us an email at sales@weatherops.com. Please also make sure to follow us on Facebook and Twitter, where you can find us at Weather Deck Tech. Thanks again for tuning in. We hope you have a wonderful spring season and a great day.